Bismillahir Rahmanir Rahim. Unit number 14, current electricity. This is exercise for MCQs, Physics 10, National Book Foundation. Question 1. A current of 10 milliampere is flowing through a wire for 10 seconds. What is the amount of charge flowing through the wire? Now, electric charge Q is equal to I times T. Substitute I is equal to 10 milliampere, that is 10 times 10 power minus 3 ampere. T is equal to 10 seconds. Now the charge Q is equal to 10 times 10 power minus 3 times 10. Now solving this 10 times 10 becomes 10 square times 10 power minus 3. Now adding these two powers for the base 10, 2 minus 3 results in 10 power minus 1 coulombs. So electric charge is 10 power minus 1 coulombs. The correct answer here is answer C, 10 power minus 1 coulombs. Question 2. 1 ampere current is passing through a conductor. How many electrons pass through its cross-sectional area in 1 second? Now again, electric charge Q is equal to I cross T. Now 1 ampere current in 1 second gives charge Q is equal to 1 times 1 is equal to 1 coulomb. Now using formula Q is equal to NE, where Q is the charge, N is the number of electrons, and E is 1.6 into 10 power minus 19 coulombs per electron. That is charge on 1 electron. Now calculate the number of electrons using N is equal to Q over E. Substituting the values, N is equal to 1 over 1.6 into 10 power minus 19 is equal to 6.25 into 10 power 18 electrons. So the correct answer here is D, 6.25 into 10 power 18 electrons. Question 3. If voltage applied on the bulb is doubled, then its power becomes. Now, voltage on the bulb is doubled. That means if a bulb is connected with a battery V volt and current I is passing through it, doubling the voltage means connecting another voltage source with it or the cell of the same capacity. Once the cell is added, it will also increase the current, because recall that according to Ohm's law, the current I is directly proportional to the voltage V. That is, I is directly proportional to voltage V. Therefore, when voltage doubles, the current also doubles. Since electrical power is given as P is equal to VI, now doubling the voltage as well as the current means the new power becomes 2V dot 2I. Now multiplying these twos, the new power becomes 4 times VI, that is the original power times 4. So the answer here would be the power becomes 4 times. Question 4. Electron volt EV is not the unit of. Now, electron volt is the energy that an electron gains when it accelerates in a potential difference of 1 volt. Value of 1 electron volt in joules is given as 1 electron volt is 1.6 into 10 power minus 19 joules. From the definition above, it is clear that EV, electron volt, is a unit of energy, and electron volt is not the unit of electric potential. So from the given options, A is electric energy, work is also similar to energy, electric potential is different from the energy, and heat energy. So the only option available to us for this question, electron volt, is not the unit of electric potential. Question 5. By applying a potential difference of 10 volt across a conductor, a current of 1.5 ampere passes through it. How much energy would be obtained from this current in 2 minutes? The electrical energy E obtained when by applying potential difference V is equal to 10 volt that causes a current I is equal to 1.5 ampere across a conductor for time is equal to 2 minutes, that is 2 times 60 is equal to 120 seconds, can be calculated using the formula E is equal to E electric energy time is equal to I times T times V. Now substituting the values, I is equal to 1.5 ampere, T is equal to 120 seconds, V is equal to 10 volts. Now calculating this results in 1800 joules. Now from the given options, 18 joules, not our answer. 180 joules, again not our answer. The other two values are given in kilojoules, so we must now convert this value into kilojoules. In order to convert into kilojoules, divide by 1000, 1800 divided by 1000 results in 1.8 kilojoules. So our correct answer is 1.8 kilojoules. Question 6. Ohm meter is the unit of resistance R of any material does not depend on the voltage V or the current I. The resistance depends on 1. The nature of the material called specific resistance or resistivity, geometrical properties like length, cross-sectional area, and number 3 is temperature of the conductor at the time of usage. Now resistance of a conductor with length L, cross-sectional area A and resistivity or specific resistance rho is given as R is equal to rho times L over A. Now solve for rho, results in rho is equal to R times A over L. Because once you isolate rho, you are taking A to the other side, that means A goes in the numerator and L is divided on the other side, that results in A over L. Now I write down the unit for R is equal to ohm, A is equal to meter square and L is equal to meter. So rho is equal to ohm meter square over meters. Simplifying this fraction, we get rho is equal to ohm meter. So ohm meter is the unit of specific resistance. Option B. Question 7. If 4 kilo ohm and 2 kilo ohm resistors are connected in parallel, their equivalent resistance is equivalent resistance for two resistors in parallel is given as R equivalent is equal to R1 times R2 divided by R1 plus R2. That is, equivalent resistance is the product over sum of the two resistors. Here, the product is 4 times 2, the sum is 4 plus 2, that results in 8 over 6, reducing the fraction results in 4 over 3, changing it into decimal results in 1.3 kilo ohm. Now this is a very simple and a handy formula used here for calculating this 1.3 kilo ohm for the MCQ which you have, and out of the given option, B is the correct option, 1.3 kilo ohm. Now, however, you may be thinking, where did this formula product over sum come from? I'll explain this further to you, but I will still insist on using this formula product over sum for the two resistors in parallel as well as for the two capacitors in series. Use the formula product over sum, that is a handy formula for MCQs and for any other place where you need to know the quick answer. Now, I'll explain this. How did you get product over sum? The formula that you know for the resistors in parallel is 1 over R equivalent is equal to 1 over R1 plus 1 over R2. Taking the LCM of R1, R2, this results in R2 plus R1, or we may say R1 plus R2. Taking the reciprocal on both sides results in R equivalent is equal to R1, R2, that is the product, R1 plus R2, that is the sum in the denominator. So R equivalent is equal to product over sum. If a current through a fixed resistance is doubled, then energy dissipation. The formula for the dissipation of electrical energy E involving current I, resistance R and time t is given as E is equal to I square R T. Since only current I doubles, that is, current becomes 2I, other variables remaining same, the energy dissipation becomes E dash equal to 2I square RT. Now squaring this 2I results in 4I square RT. Again, I square RT is the same our original energy. That means our energy becomes 4 times the original energy once current is doubled. Question 9. Fuse is always connected in series with. Fuse is a very low price device and is used to protect the electrical appliances and any electrical circuit in house, office or industry. The purpose of the fuse is to blow itself and disconnect the current flowing to the appliance in case of extraordinary flow of electrical current or rise in voltage to protect the expensive appliances. And this may happen due to any fault in the line or any problem in the transmission or maybe any other reason in the house itself. Since it is the live wire that carries the current to the appliances, therefore fuse is always connected in series with live wire. So the correct answer here is live wire. Question 10. With increase in temperature of thermistor, its resistance. In ohmic resistor, the resistance remains constant over a certain range of voltage and temperature. However, in non-ohmic resistor, this is not the case. Thermistors are the non-ohmic resistors, and thermistors come in two types: NTC, negative temperature coefficient, and PTC, positive temperature coefficient thermistors. In NTC thermistors, increase in temperature decreases resistance. Conversely, in PTC thermistors, increase in temperature also increases the resistance. Hence, the correct answer here is it may increase or decrease. Thank you.